Good morning students. Today let us continue from Kinetic effect. Okay. Kinetic effect is also influenced by entropy effect. Okay. Now what is entropy effect? Greater the number of chelate rings, greater is the stability of the chelate. This greater stability of the complexes having more number of chelate rings is due to greater increase in the positive entropy of the system. Okay. Now, for example, in CO in H2O 4 times 2 plus there is one chelate ring. During its formation from aqueous solution there is an increase in the number of particles from 2 to 3. You can see here in this example CO H2O 6 times 2 plus in gives CO H2O 4 times 2 plus 2 H2O. Okay. So, here number of particles are 2, that means one particle of this complex hexa aqua complex, another one in, that means 2 particles. Here 1 plus 2, that means 2 molecules of water, 1 molecule of tetra aqua. Okay. So, total number of 3 particles. So, this is called entropy effect. Okay. Next slide. Nature of the solvents. Solvents with the low dielectric constants and low dipole moment increase the stability of the complexes. Okay. Now, which is the example for that? Complexes of metal chlorides are more stable in DMF. What is DMF? Dimethyl formamide. Okay. Compare DMF compared to water due to low dielectric constants and low dipole moment. Okay. Next slide. Substitution reactions of square planar complexes. Substitution reactions of square planar complexes of platinum 2 are very slow. The mechanism of substitution reactions of square planar complexes appears to be associative SN2 rather than SN1, which is dissociative. This is clear from the following observations. In the case of square planar complexes of nickel 2, palladium 2, platinum 2, 5 empty metal orbitals, that is 1d, 1s and 3p of comparable energies can be made available on sigma bonding. Alright. Since only 4 ligands are to be sigma bonded with the metal ion, only 4 of the 5 orbitals of the metal ion are used for this purpose. The 5th orbital can easily accommodate electrons from the attacking ligand. So, a 5 coordinated intermediate or activated complex is formed from a 4 coordinated square planar complex through an associative SN2 mechanism. Alright. Next slide. You can see here SN2 mechanism for substitution reaction is diagrammatically represented. Okay. Now, the ligand Y, you can see here the ligand Y attacks M, okay, M attacks M from Z direction. This direction is Z direction, okay, by using pz orbitals of the metal atom to form a 5 coordinated square pyramidal intermediate. So, this is 5 coordinated square pyramidal intermediate, okay, and then transforms into a more stable TBP. What is TBP? Tributyl phosphate intermediate. This again gets converted to another square pyramidal. Okay. So, this is one 4 coordinated. Okay, 4 coordinated. This again the more stable, this again converted to another square pyramidal. So, this is one another square pyramidal intermediate containing, okay, containing one the leaving group X along the Z direction, leaving group X along the Z direction. Okay. The removal of X from this intermediate yields a substituted square planar complexes. So, removal of X results in one the substituted square planar complex. The reason for this interconversion less energy of activation of TBP. Okay. Next slide. What is trans effect? Okay. Trans effect is the important factor to understand the kinetic behavior of square planar complexes. Now, what is the definition of trans effect? Trans effect of a group is defined as the effect of a group coordinated to metal ion which has the tendency to direct an incoming group to occupy the position trans to that group. There are two theories. Okay. Now, which are the two theories? First one is polarization theory. Now what is polarization theory? Sigma effect is due to the polarization of electron density at the trans ligand, making it easier for the incoming ligand by depleting electron density at the trans position. Okay. Next is pi bonding theory. Most of the ligands exerting a strong trans effect are pi bonding. The ligands lying at the end of the series have vacant pi or pi star orbitals which can accept electrons from the metal orbitals to form metal ligand pi bond. Alright, these ligands are called pi bonding ligands. Now, what is the order of trans effect? The order of trans effect is C2H4 greater than Cl minus greater than NH3. Okay. In the case of chloride, bromide and iodide, the polarization increases in the order which is the order of, in the case of halides like chloride, bromide, iodide greatest one. Okay. Next comes bromide, next comes chloride. Okay. Now, next we shall see applications of trans effect. Okay. Trans effect is significant in the synthesis of certain cis and trans complexes. Now, which is the example for that? Synthesis of cis diamine platinum chloride complexes. Okay. What is the formula of that? This is the formula. Okay. Diamine, two amine ligands are there, platinum and Cl2. Okay. Now, what is the oxidation of state of platinum over here? +2. Okay. Amine ligand 0, oxidation state, chloride -1, chlorine is -1, 2, therefore -2. Okay. -2. So, this is the complex. Alright. So, ammonia being added plus ammonia and Cl minus is removed. So, you have NH3 here. Okay. Once again one more amine ligand is added. Okay. So, it is added here, one more Cl minus is removed. Okay. Next line. Now here Cl minus is added and amine NH3 is one. Okay. So, in this process, in the previous process here, initially one Cl minus is replaced by NH3 to give PtCl3 NH3 minus ion. Okay. The ions which is more labile are circled. Okay, more labile are circled over here. The Cl minus stands to amine is not labile because the trans effect of NH3 is less than that of Cl. Okay. In the next step, greater trans effect of Cl over NH3 is used. Thus, one of the circled Cl minus is replaced by NH3 to obtain cis product. Okay. So, next line you can see here 4 amine ligands are there. One Cl minus is added, one amine is ligand. Okay, one Cl minus is added. You can see here one amine is removed. Now, in next step, one more Cl minus is added, amine is removed. Okay. In the first step, the one NH3 is replaced by Cl minus to give Pt NH3 tries Cl positive ion. Okay, Cl positive ion. This is the ion. In this complex ion, the NH3 trans to Cl minus is more labile. Okay, more trans to NH. That means this one is more labile. Due to greater trans effect of Cl minus over NH3, trans Pt NH3 Cl2 is formed. Okay, this complex is formed. Alright. With this chapter is over. Okay, so please go through all these lines. Any difficulty, please contact me. Okay. Thank you.